So today the last topic this semester it is the Shannon decomposition. It is expansion with one variable. You can see the formula on slide number 2, the second page. And this formula is if we would like to use f of n variables x1, x2, and so on as n. So it can be represented as, for example, here is variable xi, and we need to remove this variable in this function. For example, let's use example. Some example. F of x1, x2, x3, just three variables, and it is not x1, x2, x3 junction x2 not, x3 not, disjunction x1 not, x2, x3, for example. And we decided to remove x1, for example, x1. With using Shannon decomposition or Shannon expansion. So the formula is x I with conjunction where x is to 0. Then, so this is the first formula on the slide. Then disjunction xi without negation conjunction f with where xi equals to 1. So I wrote here different structure formula, but this is two formulas the same. And so how we can get f of xi equals to 0? For example, we use x1. We would like to delete x1 from this expression. So we need to get f of x1 equals to 0. So this is very easy. So this expression where x1 equals to 0. So not 0 conjunction x2 conjunction x3 disjunction not x2 not x3 disjunction 0 not x2 x3. So this is our function where x1 equals to 0. Hope that it is very easy and very clear. If not, repeat this one. Our f, where x1 equals to 0. So this is f of 0, comma x2, comma x3. Instead of x1, 0 here and here. Instead of x1, 0. So this is function, our function, where one of variable equals to 0. So f of 1, x2, x3, it means instead of x1, I'll put 1. It will be what? Not 1, x2, x3, disjunction, not x2, not x3, disjunction 1, not x2, x3. So here is result. X2, x3, disjunction.
Not x2, not x3.
Not x2, not x3. And here will be result which one?
x2, x3. No. Not x2, not x3.
Not 1.
0.
Here, not 1 will be 0. So this part disappeared.
Not x2,
not x2, not x3. Disjunction.
Not x2, x3.
X3. And all expression will be for this example. This example. So if we would like to remove from this function x1, according to Shannon decomposition, we need to use this formula, or the first formula from the second slide. They are the same. So not x1, conjunction f, where x1 equals to 0. This is function x2, x3, disjunction, not x2, not x3. Then disjunction, then x1 conjunction f, where x1 equals to 1. Yeah. x1 conjunction f, where x1 equals to 1. Okay, and you can use the laws from Boole algebra here. Bloom law. Bloom law. What will be the result?
Not x2. X3 and not x2. That's also.
Not x2.
Yes.
Not x3. X3 blue. Yes.
1.
Not x2. Okay, so here will be function where x1 equals to 1, and it is not x2. So this is Shannon decomposition for variable x1 according to formula. So we will take all x2, x3, and with the same list. This is just for one variable, yeah, and the ultimate Shannon decomposition.
Are we going to do for each of the element over there, or it will be just for x1 always?
This is example just for x1. In your coursework, you need to delete step by step one variable, then another, then another.
For each of them.
Yeah, and you need to get so Shannon blocks. How will be Shannon blocks? What is it? So this is exit. It is our f of three variables: x1, x2, x3. Yeah.
Yes.
Then
Over there, x1, x2, x3.
what is in what will be inside?
Conjunction.
Disjunction, two conjunctions.
And
Yeah.
yes.
So disjunction of two expressions, this one and this one. So here will be conjunction. Yeah. Here will be also conjunction. How many inputs?
Two input.
How many inputs?
Over here. Three. No. First one, two input, then two input. Then we can, if
Plus two?
two plus two, four. Yes.
Four. So one,
Yes.
two, four. 1, 2, 3, and
Four.
yes, four inputs. Four inputs. But these two inputs, it is xi without negation and xi with negation. So we can do like this. There is negation.
Negation is in the first one.
Yeah.
Up. Negation is up.
Up. So x1. x1.
X1 is equal to 0. Like that.
Yeah, x1 here. x1. Then, so x1 here, then function f of 0, x2, x3.
Yes.
And here, here x1 without negation. So here f of 1, x2, x3. So this block and this expression absolutely this one, this expression absolutely the same. So this is f 0, x2, x3. This is f of 1, x2, x3. So we do have questions. So this block and this expression are the same. Okay, so ultimate Shannon decomposition. when we, I hope it is. You remember our truth table?
Yeah.
And we get expression with disjunction, conjunction, and negation from this truth table. So Shannon decomposition, ultimate Shannon decomposition. So for our F, for example, F of x1, x2, x3. So ultimate Shannon decomposition. It means that we eliminate all variables, and the result of ultimate Shannon decomposition will be not x1 conjunction not x2 conjunction not x3 conjunction f of what?
We take all of them, it would be 0, 0.
0, 0, 0. F of 0, 0, 0. Disjunction. Then another combination.
X1,
Not x1, not x2, x. Conjunction F of
0, 0, 1.
0, 0, 0, 0, 1. Conjunction not x1, x2, not x3. F of 0, 1, 0. Disjunction. And so on. How many expressions like this one?
8 expression. 8
How
expression.
8 expressions.
Yes.
Because of 8 points, because of 8 combinations with negation and without negation with 3 variables. How we counted it?
2 by the power of 3.
2 to the power of 3. Where 3 it is number of variables, and 2 means every variable can be with negation or without negation. 2 power 4, that's 16. 2 to the power of 4, 16. Yes, 4. 1, 2, 3, 4. Yeah, if we have 4 variables, then 16 combinations. Yeah. So and so on, and disjunction x1, x2, x3, conjunction f of 1, 1, 1. So this is the ultimate Shannon decomposition. Do you have questions? Yeah.
Yeah, so but there's something I've not understood very well, like the expression just written there. Is it part of the other question, or this is just different on how to show us on how the expansion has to?
This expansion just one variable. This expansion 3 variables for one step.
So if we want to solve,
So this expression and this expression will be the same. The result is the same. If you would like, we can check.
No, they kind of like where is the not 1, not x2, not x3 kind of thing?
Not x1, not x2, not x3. Conjunction, result of function in this particular point So 0, 0, 0, function of function f, where x1 0, x2 0, and x3 0. What will be the result?
They are all zeros.
0, 1,
This
0. So it is 1. So the result will be not x1, not x2, not x3, conjunction 1. Disjunction, no, conjunction 1 means that this expression will be here. Then disjunction, the next point, 0, 0, 1. 0, 0, 1. 0, 0, and 0. So f of 0, 0, 1, according to this expression, equals to 0. So disjunction 0 or disjunction nothing for this point, and so on.
and that's the question. We are seeing that the not x1, not x2, not x3. On the after the disjunction, it has changed. Now it is not x1, not x2, x3. So that expression, is it what does it depend on? The change?
In ultimate Shannon decomposition, we use here all expression or all kind of expression with three variables, with conjunctions and negation or without negation for each variable. So this is the first one. It is 4.000. This is the first combination. This is the second combination. Then this combination. It is 0, 1, 2, then 3, 4, 5, 6, 7, 7. That's all. 7. It is 1, 1, 1. And that's all because just three variables. 3 variables, 8 variants, 8 points. Of combinations with negation or without negation for each variable. For 2, it would be 0, 1, 0. For 2 to the power of 2, it is 4. 0, 0, 0, 1, 1, 0, 1, 1.
Like 2 power 3 is 8, 0 to 7 is 1. So if we are taking 2, like we are taking 0, then 1 and 2. So for 2, it will be 0, 1, 0 in the two together.
Two variables, you mean?
Variables for what? For 2, it will be 0, 1, 0, 0, 3 variables.
Okay.
0, 7. The next will be 0, 0.
0, 1, 0, 2. Yeah. 0, 1, 2. 0, 1, 0 is 2.
If 0 is
0, 1, 0, it is a binary system of digit 2 in decimal system.
no, I'm saying your x1 will be 0, the next day your x1 is 1. And
x1, 0, x2, 1, and
x3 is 0, so we will take 0 to 7.
from 0 to 7.
Like
Yes. Okay. So on. So maybe more questions? Before questions, more?
I have a question that
Okay.
we are going to get that expression from our own work, minimization, right? That one.
Yeah.
After that, we have to evaluate, do the Shannon decomposition. Either we can do like that one, or if it is four variable, we can continue with four variable like this one.
You asked about our coursework.
Yeah. I am.
So in our coursework will be tasked make a scheme of our function with using block of eliminating one variable.
Each time one.
Just with these blocks. So the same task as previous class, but previous class we used elements from our basis.
Yeah.
And now we need to use just blocks, just block, Shannon block of eliminating only one variable. So ultimate Shannon, it is just for you teaching, just to know about.
Just to know.
Just to know. For example, so yeah. To know to example. But this block, you need to use this kind of blocks. You need to use to build a scheme of our function. So let's do it for this function, and then.
So just one question.
Okay. Yeah.
Let me just stop here and I show it. Like now, for example, for this one, we can consider this like this thing.
Not without not.
So that was
0, 1, 0.
So we can consider that.
The same idea, yeah, the same idea. If x1 with negation, then instead of x1 we put 0. If x2 without negation, then instead of x2 we put 1.
And it's general for
It's-
that. Yeah. Decomposition. No problem for one. Yes, yes, yes.
Okay, so let's do it. So first of all, we eliminated x1. This is our function f of x1, x2, x3. It is not x1, x2, x3 disjunction, not x2, not x3 disjunction. X1, not x2, x3. This is Shannon block. So Shannon block, it is 1 disjunction, 2 conjunctions block inside, eliminating variable with negation or which. Okay, it doesn't matter. It is very important if you put here negation, so here must be f, where variable fi equals to 0. This is important. If you put here negation, so here must be function where fi equals to 0. So, okay, so x1, we eliminate x1. Then here will be f of x1 equals to 0. It is x2, x3 disjunction, not x2, not x3. And here f of x1 equals to 1. It is not x2, not x2. So from this expression, from this function, we need to eliminate x2 or x3. So what would you like to eliminate? Which one? X2 or x3?
How can I eliminate?
Using which
With your choice. Absolutely the same.
X2, X3, first one.
X2, yeah?
Yeah.
Okay, x2. So we need to eliminate x2. So here will be x2 with, but in your coursework, if you use block where negation the first, so please use the same blocks. Yeah, if negation here, so everywhere negation here, the same blocks. So conjunction, disjunction, and here will be f of 0, 0x3 equals to what? So this is f of 0x2, x3. This is f of 0, 0x3. So instead of x2, I need to use here 0. It will be 0, conjunction x3, disjunction, not 0, conjunction, not x3.
Not x3,
so the result will be what?
Not x3.
Not x3. 0, x3, disjunction 1, not x3, it is not x3. Yes. Here.
Here.
F of 0, 1, x3.
X3, yes. Yes, here it will be x3.
1.
Yes, x3.
Not 1.
Not
x3. So x3, this is the simplest. So this is just variable without operation. So this is just simple input. So this is input, the end, this is input, the end, and here not x3. So we need to use one more block here. On the slide in presentation, we can see that I used block negation. But I asked you not to use block negation because it is different block. So in your coursework, please use just blocks, just Shannon blocks.
Okay.
Without blocks of negation, conjunction, disjunction, just Shannon. Okay. So it's in your coursework we can't use this block because we don't have, for example, we don't have block like negation in our pocket. So we need to use here also Shannon block, and it is easy. So it will be Shannon block, the same disjunction, conjunction, and we need to eliminate which variable?
Just for x3.
Just x3, without options. Yeah, without options, x3. And we can use variables for inputs and 1 or 0 also. It is possible to use 1 or 0. So here will be what, and here will be what?
The upper one will be
f of
0, 0, 0.
equals to 0, x3 equals to 0.
The first one will be f0, 0, 0. The second one will be f0, 0, 1.
Yeah, right.
Like that.
And the result?
The result
of 0, 0, 0. instead of x3 will be 0.
0, 1
Not 0,
is 1.
1. Not 0, it is 1. And here,
0
not 1.
is 0.
So instead of x3 now 1.
1,
I put here 1, not 1, it is
0.
0. Not 1, it is
Yes, can you repeat? Can you repeat how it's got the 1 up there?
This is our function. This is input. And for this input, we have function like this. This is name of our function. This is expression of our function, not x. This is block of Shannon block of eliminating variable from this expression. In this expression, we have just one variable, it is x3. So we eliminate x3. So this is standard block, disjunction to conjunction, eliminating variable with negation and without negation. Here negation, that is why here f, where x3 equals to 0, this f, where x3 equals to 0. Here, input for f, where x3 equals to 1. Equals to 1. So I just, instead of x3, in this function, put 0 and get the result of this input.
No, not 0 equals to 1.
Yeah, 0. So not x3, it is not 0, it is 1. This is a result for this input. Here, here will be f, where x3 equals to 1. This f, because this is the result of this block Shannon. And this input for this block. So instead of x3, 1, not x1, it is 0. That is why here 0. And the easiest input, the easiest. So we stop here. But we need to finish this this part. So here not x2, so we need to add one more block, Shannon block, eliminating x2. Disjunction, conjunction, conjunction. If you want, you can use like this conjunction, but everywhere to use one
thing.
The same. Yeah, I think it will be better. Okay. So eliminate x2. Here must be function f, where x2 equals to
1. Not 0, it's 2, it is 0. 0, yes.
Here f,
0.
where x2 equals to 0. This is f, not this one, but this one, because this is output of this block and input for this block. So instead of x2, I put here 0 and not 0, it is 1. And here f, where x2 equals to 1. Instead of x2, 1, not x1, it is 0. Very similar, just x3 here and x2 here, and others the same. Because here not x2 and here not x3.
Yes.
So it is very logical. Questions?
So, like, are there some situations whereby, are there some situations whereby we might be having a different structure of a diagram? For example, there at X1, the first block, the very first block, whereby it's not, for example, we have not X1 and X1. So is it possible to have a situation whereby the X1 there on the first block is different?
You mean not x1 here?
Yeah, maybe we have
And-
It is not
it's
possible.
not possible.
It is not possible because the x1 has only two situations, either not or yes. Yes, how?
So you can use another block just to change positions.
Like, is it okay to change positions or?
But you need to change this function
Different
also. Then it will be the same block. But
But
The upper one is a 0, then the down one is a 1.
if you write like this one, so this is x1, this is not x1, then you need to change positions. This is here, and
That one
this
is-
is here.
yes, but his mean was like
That's
this.
so, and
X, no, for both of them, x1, not x1, not x1. It is not possible.
Maybe I can be having X1 only.
No, it's not possible. Yes, either is
because of formula.
yeah, because of as well, and in normal life as well, it is not possible. Not x1 is only one.
Yeah. So this expression equals to this expression. If x1 is negation, then function of x1 equals to 0.
Yes.
If x1 without negation, then in Boole algebra, where we work with digit 0 and digit 1, two variant of values of variable. And you can get another scheme. It will also work another scheme. I mean, if you eliminate, first of all, not x1, but for example, x2. So it will be different blocks, different scheme, but the same result. So you can eliminate x1, first of all, or another variable.
Then
Uh,
then the other one. First x1, then the x2.
First x1, then x2, or first x3, then x1.
So I can start with anything I want, with any.
It depends of real task. If we eliminate x2, first of all, maybe we will get shorter scheme. Because f2 here and here and here, maybe. It is not the rule, but maybe.
So at least eliminate maybe the variable I want to eliminate as maybe it appears maybe two times in a function of 3 variables. Like that one is okay. Like if it's not appearing in every block.
It can be function where you eliminate one variable and it is finished. It can be.
So it is correct.
Yeah, it's correct. Yeah, for focus work, I don't ask you to eliminate a particular variable like you want. Do you have questions? So this block, instead of negation block, you need to use not X3. So this particular block for not X3 instead of block on slide. Yeah?
Yes.
So this is not X3. Not X3. This is block negation. So instead of this block, please use this Shannon block in your coursework. So our scheme consists of Shannon's blocks also, or only.
Only Shannon.
Or only
Yeah,
Shannon.
that
Only
is a
Shannon.
good one.
Without addition block of other. And you can see another example in presentation or more practice. Okay. So we have questions about your coursework.